Okay, so today we're talking about all the different types of factoring. We've talked about 5 different types. The GCF, which is here in the center. We've talked about when we have 4 terms, we factor by grouping. We've done the trinomial where the beginning term is not 1, and we use the X method. We've talked about the trinomial using the X method, but not the full steps, and using a shortcut because of the A is 1. And we've talked about the difference of squares, which is also kind of a shortcut. So let's put it all together. Basically what you need to do is start categorizing the types of factoring by how many terms there are. So like for 4 terms, we know we do grouping. So then right away in this example, we group them into pairs using parentheses. The GCF of the first pair is a squared, and the GCF for the second pair is 5. So we get a squared times 2a minus b plus 5 times 2a minus b. And as you remember, we put both GCFs, so the a squared plus 5 is one factor, and then the one that was the same, the 2a minus b, is the second factor of the answer. And when I say factor, it's like we know 4 times 5, 4 and 5 equal 20, so 4 and 5 are the factors, and so this times this equals the original, so these are the 2 factors. Okay. Now when there's a trinomial, we're going to use the X method. We have to set up whether there's A is 1 or not 1. We're going to both set up the X, where you do A times C as your product and your B as your sum, and you have to find the 2 numbers. When A is not 1, however, you have to do the full steps. Okay. But when A is 1, you can do the shortcut. Okay. But they both start with the same X. Now, looking at the example for the full X method, we have 30x squared minus 27x plus 6. Now, see how it said look for a GCF first? I kind of glossed over this. The 4 terms did not have a common factor. And I did not, well, first of all, I recognized this was minus 1. So as soon as there's a 1 or a minus 1 for an like when it says look for a GCF, we're talking about an overall GCF for all the terms. So as soon as I saw this minus 1, I know there cannot be coefficients that have a greatest common factor. So then I look at the variables. Well, this doesn't have a b, and this automatically doesn't have an a, so I forgot to tell you guys the reason why I skipped over this first step is that I automatically recognized it did not have it. That's how quick you're going to get to the point, especially by Algebra 2 pre-calc, how good you got to get at factoring that you can recognize right away if there's an overall GCF. So like in the next example under the full X method, I automatically recognize that there's an overall GCF of 3. Don't start the X until you take out the overall GCF. You just have to remember though that this has to go in the final answer. So what you might want to do is go ahead and just set up, I'm going to box my final answer with the overall GCF in front because that's one of the most common mistakes I see and I'm still seeing. And then the 2 factors once we get the full X method completed. Well, once we reduce our GCF, we have 10x squared. I just blanked out. Minus 9x plus 2. Now I know I've taken out the overall GCF because 10 and 9 have no common factors. Or you can think of it as 9 and 2. And there's not a common variable throughout. Okay, so let's go straight to the X then. Now we can do our A, B, and our C. So again, let me emphasize, do not do the X until after you've taken out any possible overall GCF. Now, maybe let's make a little note. First, look for a GCF, in other words, an overall GCF for all the terms, if it exists. They're not always going to be part of every problem. Just like this first one, there was not an overall GCF, but this one there was. Take out your overall GCF, then start the next part. Okay. So our A times C is 20, and our B is -9. Well, this tells me I need two negatives, so that a negative times a negative is positive, and they add to a negative. Well, 4 times 5 is 20, so a -4 times -5 is 20. And I know I can add the two negatives to equal a negative. So, because my A is not 1, I cannot do the shortcut. So these are my -4x and my -5x we're going to use to replace the old middle term. So we get our 4 terms by rewriting it as 10x squared. The first term always stays the same. Minus 4x, and then I'm going to put plus -5x plus 2 because I know I'm going to go right into grouping with those 4 terms. So the GCF of the first terms are 2x, and the GCF for the second 2 terms is -1. How do I know that it's negative? If you ever have a negative in the first term of a pair, the GCF is negative. The other way you can think of it as, see how the first pair has a positive, then a negative term? The second pair has a negative, then a positive. That's opposite. We need them to match for the next layer to finish factoring. That's another way you can look at it. So, okay, let's look at the next layer. So we have 2x times, we have 5x minus 2. And then since the GCF of the second pair is -1, we don't need the plus anymore. We do -1 times 5x minus 2, and they match now. So we put our GCFs, 2x minus 1, in one factor, and then the common factor of 5x minus 2. And then here we already have our overall GCF from the beginning. So here's the complete final answer. Now, the cool thing about the shortcut, not only do you still use your A times C, but we have A is 1, and the sum is B in our X, but we can go straight to the final answer. So in this case, my A is 1 times my C is -42, so the product is -42, and the B is -1. So I need a negative times a positive, and more negatives, so it's -7 times 6, and I can go straight to the two factors, split up the x squared, or the 1x squared, to x times x, and then we have our -7 and our +6. And that's our final answer. Now you could do your double distribution to check all of these. So real quick, we could say x times x is our x squared, x times 6 is 6x, -7 times x is -7x, and -7 times 6 is -42. But if you go back, remember I said we had the 6x and the -7x? They add to the -1x, just like over here. Now, why is the second bullet point part of the trinomial with the shortcut? If we have 2w squared plus 20w plus 50. Well, I hope some of you already recognize that there's an overall GCF of 2 that we can reduce it by, and as soon as you reduce it, but maybe we should remember, okay, we know that 2 has to be in front of our 2 other factors for the final answer to be correct, because don't ever lose that overall GCF. So when we reduce it by 2, you get w squared plus 10w plus 25. So now we have that 1w squared, so we can do the shortcut. We go straight into the x, 1 times 25 is 25, and then 10 is our sum. Well, 5 and 5 work. 5 times 5 is 25, and 5 plus 5 is 10. Now let me show you another thing. So actually, I want to change, okay, we could split the w squared into w times w, and we have a +5 for both. But this is actually not the most correct answer. I hope some of you in your head are already saying, oh, well, actually, what I should write this as is 2 times w plus 5 squared. This w plus 5, because there's 2 of the same factors, that's why you have to write it as squared. Notice none of the others that we've done so far have the same factor, okay? So we're good. All right. So again, let's recap. 4 terms, you go straight into grouping. 3 terms, you do the x, but then you do the full x method if the a is not 1. And you can do the shortcut if a is 1 even after taking out a GCF. Now if there's 2 terms, so this is the only binomial, the only way you can factor a binomial that you know of right now in Algebra 2 you learn of a different one, or a couple in Algebra 2, but for now we're only doing a difference of squares. So that means there has to be 2 terms, the difference means subtraction, and x squared and 64 both have to be perfect squares, which they are. Well, the cool thing is we just separate them, and we have the plus and the minus, so the middle terms eliminate. Basically, we square root x squared, which is x times x, and square root 64, which is 8 and 8. Now, we could do the double distribution again, and x times x is x squared, x times minus 8 is negative 8x, and then 8 times x, 8x. Those are the middle terms that cancel, and then 8 times negative 8 is our negative 64. Good to go. Oh, and by the way, and I didn't mention this in the first bullet point here either, or this one. I know there's not an overall GCF because as soon as I see there's a 1 or a negative 1, I do not look at the coefficients. And then I look straight at the variables and I notice, well, this doesn't have a variable, and neither does this have a variable, so there's no GCF possible. However, the second bullet point on this last example, there's definitely an overall GCF, which happens to be 2n. So what I'm going to do is make sure that 2n is in front of my final answer. Otherwise, your answer is not correct. Because we have to be able to do double distribution and then distribute this back to get the original. And without the overall GCF, we'd never be able to get to the original answer when we multiply it out. Okay. Well, now that we've divided out the GCF, you go ahead and say, okay, well, 18 divided by 2 is your 9. The n's divide out, so we just have our m squared. The 2's divide out, so we have minus n to the second, because we use our exponent rules for dividing. Now, this 9m squared minus n squared, I just square root and separate the plus and the minus. So 9m squared, the square root of 9m squared is 3m, so we have 3m. And then splitting up the n squared, or square rooting the n squared, is n and n. So there's our final answer. So when they're all mixed up, you need to look at how many terms there are to tell you what method you use, okay? And that's